Hello students, welcome back to the science class. In our last class, we have discussed some concepts of gravitation. In this class, we will discuss some more concepts about gravitation. Students, let us now discuss about Archimedes' principle. Archimedes was a Greek scientist. He discovered the principle subsequently named after him after noticing that the water in a bathtub overflowed when he stepped into it. He ran through the streets shouting, "Eureka!" which means, "I have got it." The knowledge helped him to determine the purity of the gold in the crown made for the king. His work in the field of geometry and mechanics made him famous. His understanding of levers, pulleys, wheels and axle helped the Greek army in its war with Roman army. Let us now discuss about Archimedes' principle. There is an activity given in your book, that is activity 10.7. It says, take a piece of stone and tie it to one end of a rubber string or a spring balance. Suspend the stone by holding the balance or the string as shown in your figure 10.6a. Note the elongation or the reading of the string or the reading on the spring balance due to the weight of the stone. Now, slowly dip the stone in the water in a container as shown in figure 10.6b. Now students, observe what happens to elongation of the string or the reading on the balance. You will find that the elongation of the string or the reading of the balance decreases as the stone is gradually lowered in the water. However, no further change is observed once the stone gets fully immersed in the water. What do you infer from the decrease in the extension of the string or the reading of the spring balance? We know that the elongation produced in the string or the spring balance is due to the weight of the stone. That means, when we put an object on the spring balance, the elongation or the reading on the spring balance that is shown is because of the weight of the stone or the object. Because what is weight? Weight is the gravitational pull. So, when the object is tied to the hook of the spring balance, the gravitational force pulls it downwards, thereby changing the reading of the spring balance. So, since the extension decreases once the stone is lowered in water, it means that some force acts on the stone in upward direction. As a result, the net force on the string decreases and hence the elongation also decreases. As discussed earlier, this upward force exerted by water is known as the force of buoyancy. Okay? Students, what is the magnitude of the buoyant force expressed by a body? Is it the same in all fluids for a given body? Do all bodies in a given fluid experience the same buoyant force? The answers to all these questions is contained in Archimedes' principle, stated as follows. When a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Now, can you explain why a further decrease in the elongation of the string was not observed in activity 10.7 as the stone was fully immersed in water? Archimedes' principle has many applications. It is used in designing ships and submarines. Lactometers, which are used to determine the purity of a sample of milk, and hydrometers used for determining density of liquids are based on Archimedes' principle. Students, let us now discuss questions given in your book. It says you have a bag of cotton and an iron bar, each indicating a mass of 100 kg when measured on a weighing machine. In reality, one is heavier than other. Can you say which one is heavier and why? Let us discuss. Students, we know that true weight, that is equal to apparent weight plus upthrust. The cotton bag is heavier than the iron bar. This is due to the reason that the bag of cotton, which has more volume as it has less density than the iron bar, which has more density, experiences more upthrust due to air. Hope you understand this. Students, let us now discuss relative density. As you know, the density of a substance is defined as mass of a unit volume. The unit of density is kilogram per meter cube. The density of a given substance under specified conditions remains the same. Therefore, the density of a substance is one of its characteristic properties. It is different for different substances. For example, the density of gold is 19300 kg per meter cube, while that of water is 1000 kg per meter cube. The density of a given sample of a substance can help us to determine its purity. It is often convenient to express density of a substance in comparison with that of water. The relative density of a substance is the ratio of the density to that of water. So, relative density is equal to density of a substance So, relative density is density of a substance divided by density of water, or we can say density of a substance in comparison with density of water. Okay? Since the relative density is a ratio of similar quantities, it has no unit. Okay? So, students, let us discuss example 10.7. Example 10.7 says relative density of silver is 10.8. The density of water is 10 to the power 3 kg per meter cube. What is the density of silver in SI unit? So, let us discuss the solution. Relative density of silver is given as 10.8 and density of water (10 to the power 3), okay, 10 to the power 3 kg per meter cube. Fine. We know that relative density is equal to density of substance divided by density of water. So, from this we can find out that density of substance is equal to relative density multiplied by density of water. In this case, relative density of silver is given as 10.8 and density of water is 10 to the power 3 kg per meter cube. Fine. So, it gives us 10800 kg per meter cube, or we can write 10800 kg meter to the power minus 3. Okay. So, density of silver is equal to 10800 kg per meter cube. Hope you understand this. Let us now discuss what you have learned in chapter gravitation. The law of gravitation states that the force of attraction between any two objects is proportional to the product of their masses and inversely proportional to the square of the distance between them. The law applies to objects anywhere in the universe. Such a law is said to be universal. Gravitation is a weak force unless large masses are involved. Force of gravitation due to the earth is called gravity. The force of gravity decreases with altitude. It also varies on the surface of the earth, decreasing from poles to the equator. The weight of a body is the force with which the earth attracts it. The weight is equal to the product of mass and acceleration due to gravity. The weight may vary from place to place, but the mass stays constant. All objects experience a force of buoyancy when they are immersed in a fluid. Objects having density less than that of the liquid in which they are immersed float on the surface of the liquid. If the density of the object is more than the density of the liquid in which it is immersed, then it sinks in the liquid. Hope you have understood all these points. Now, let us go for the exercises and discuss the questions. Students, let us now discuss question number 2. Gravitational force acts on all objects in proportion to their masses. Why then a heavier object does not fall faster than a lighter object? Let us discuss the solution. Students, gravitational force acts on all objects in proportion to their masses, but a heavier object does not fall faster than a light object. This is because of the reason that acceleration is equal to force by mass. Okay, or force is equal to acceleration into mass. So, force is directly proportional to mass, acceleration is constant for a body of any mass. Okay, hope you have understood this. Students, let us now discuss question number 3. It says, what is the magnitude of the gravitational force between the earth and a 1 kg object on its surface? Mass of the earth is 6 into 10 to the power 24 kg and radius of the earth is 6.4 into 10 to the power 6 meter. So, let us discuss the solution. The gravitational force between the earth and 1 kg object on its surface is given by F is equal to that means gravitational constant, mass of earth and mass of body divided by radius of earth square. Okay. So, it is 6.67 into 10 to the power minus 11, that is the value of the gravitational constant. Mass of earth, that is given as 6 into 10 to the power 24, mass of body is 1. Okay. Radius, it is given as 6.4 into 10 to the power 6 square. Okay. When we calculate, it gives F is equal to 9.8 Newton. F is equal to 9.8 Newton. So, this is the gravitational force between earth and a 1 kg object on its surface. Hope you have understood this. Students, let us now discuss question number 4. It says, the earth and the moon are attracted to each other by gravitational force. Does the earth attract the moon with a force that is greater or smaller or the same as the force with which the moon attracts the earth? Why? Okay. So let us discuss the solution. Students, the earth attracts the moon with a force equal to the force with which the moon attracts the earth. This is because as per Newton's third law of motion, forces of action and reaction are always equal and opposite. Okay? Hope you understand this. Students, let us now discuss question number 5. It says, if the moon attracts the earth, why does the earth not move towards the moon? Okay? So let us discuss the solution. Students, both the earth and the moon attract each other with the same force. But according to Newton's second law of motion, acceleration produced in a body by any force is inversely proportional to the mass of the body. Since mass of the earth is much more than that of the moon, the acceleration produced in the earth is negligible. As a result, it appears as if the earth does not move toward the moon. Hope you understand this. We have discussed up to question number 5 of the exercise. I hope you have understood all the concepts. So I wish you go through all the questions and I know you can solve all of them. Okay? Students, with this we have come to the closure of today's science class. We have discussed some more concepts about gravitational force. We have discussed some questions to understand the concepts in a better way. You all should revise the chapter and go through all the concepts, because the more you revise, the better you understand. Okay students, so keep practicing, keep revising and be safe and keep smiling. Thank you.